So now let's try to derive the Liouvilles theorem. So for that purpose, we choose an arbitrary volume in the phase space okay. Right. So I choose an arbitrary volume. Say if I represent it by phi. In the part 3, I guess it was omega, but I purposefully used the term phi because we just now, only last week we used the term omega for the number of microstates. So in order to avoid any kind of confusion for a not so keen learner, let's avoid the word omega for that while. Let's use the term phi. And so that is the arbitrary volume I have chosen in this phase space. And its surface I represent it by sigma. The surface of the arbitrary volume, I call it by the term sigma. Now, what are we dealing with? We are basically concerned about the movement of the density function. Density function means it is a representation of the distribution of representative points in the ensemble. So we are basically concerned about the movement of the rho, movement of the density function in and out of this arbitrary volume. And my duty is to check what will be how the rho will change with respect to time, especially for this arbitrary volume I have chosen. Which means that I need to have an idea about how does the representative points increase and decrease in this phase space. Basically, it's a concept of how far it is going out, how far it is coming in, right? So I can write that the rate at which number of representative points increase in the volume phi can be represented as given by dou t integral over phi rho d phi, right? So what is this d phi? You know that because we are staying in the phase space, which means that I have the q and the p coordinates there. So d phi is equal to d raised to 3n q d raised to 3n p. So this is the rate at which the representative points will increase in my in the volume I have chosen. Now there will be flowing out of the representative points So the rate at which the representative points flow out of phi is given by its divergence, right? Because you know that is the concept of divergence. So called your yeah, whatever. Let me not digress into various other things. So the rate at which the representative points flow out of this chosen volume is given by its divergence. So I have to just write down the divergence of that system. Integral over phi div of rho v d phi. So what is v? V is the velocity vector of the representative points. So we have written the rate at which the number of representative increase and the rate at which the representative points flow out of phi in these two expressions. Now I need to do another simplification with the div, since we have written div of that quantity, right? This is what we have written the div. I can write the div of rho v is equal to sum over I is equal to 1 to 3n. This is general expression of div and I am just using it. Dou by dou qi rho qi dot plus dou by dou pi rho pi dot. Right, in terms of the q and the p parameter, we can express this rho v like this. Sum over I is equal to 1 to 3n dou by dou q of rho qi dot plus dou by dou qi dou pi of rho pi dot. So that is it. So now we have the two expressions coming in and the going out of the phase points, right? So now what we can do is that although we have written of the origin and the disappearing of the phase points in this volume, in this designated volume phi, we know one thing, that there is no source or sink in the phase space, right? So what does that mean by? See, it means that the number of representative points in that typical volume should be conserved. Therefore, the number of representative points should be conserved. So therefore we can equate those two expressions, right? This one and this one. We will equate and we can write dou by dou t of integral over phi rho d phi is equal to minus of integral div of rho v d phi. See, we know that the div of a flowing out quantity is a positive quantity, right? If it is the flowing out means it's a positive divergence, and flowing in means it is a negative divergence. So that is why we have used keep the positive over here. But now when we are equating, I purposefully put the negative number there because these are two opposite actions. It is just not equating, right? These are one does not help to build other. This is a mutually actions which are mutually against each other. So therefore, I have put, in order to denote that, we have put the negative number there. So that is it. So if I simplify this, I can write integral dou rho by dou t plus div of rho v d phi is equal to 0. Right? I just took this to this side. Now this has to be 0, which means that my sufficient and necessary condition for this expression to get satisfied is what? This quantity should be now 0. Sufficient and necessary condition, which I can write it as dou rho by dou t plus div of rho v is equal to 0. Now I know I have written down the expression for div rho v over here. So I substitute, I can take it to here and I adjust the order of the terms in order to suit my simplification. So I will do this in one single step. You can do this in a couple of steps where first you substitute for the div of rho v and then you do the reorganization. But I will do this in one single step. And I can, what should be my equation? Okay, so you know that. So, so therefore, dou rho by dou t plus sum over I equal to 1 to 3n dou rho by dou t dqi dot plus dou rho by dou pi dot plus, right? I have taken, I'm taking, basically I have applied the integral, the differentiation inside, and I am splitting the terms now. So this is the first set of terms, and the second set of terms could be rho into sum over I equal to 1 to 3n dou qi dot by dou qi plus dou pi dot by dou pi is equal to 0, right? This 0. Oh, sorry, here, this 0. The right hand side was 0 in anyway. So I put the right hand side. So in the left hand side, I just put the div rho v equation over here, put the integral and took the differentiation, and I reorganized the terms to suit my convenience, and I finally got this one. So let me ask you, you have studied quantum the classical mechanics. So what is the term? What will be the value of this one? dou of dou qi dot by dou qi plus dou pi dot by dou pi. What will be the value of that one? Try to do it yourself, and we will continue in the next video. So before watching the next video, try to solve this out.